Microsoft PL300 Exam Profiling and Handling Data Quality Issues Guide. This tutorial and study guide will cover the Profiling and Handling Data Quality Issues section of the PL300 exam in detail. The aim is to equip you with the knowledge and skills needed to confidently answer exam questions and apply these concepts in real-world scenarios. 1. Understanding data profiling in Power BI. What is data profiling? Data profiling is the process of examining the data available from an existing source and collecting statistics and information about that data. It helps you understand the quality of the data, identify patterns, anomalies, and areas where data cleansing is needed. Why is data profiling important? Identifies incomplete, inconsistent, or inaccurate data. Highlights potential data quality issues such as missing values, duplicates, and outliers. Ensures that data meets business requirements and is ready for analysis. Key data profiling tools in Power Query. 1. Column quality. Shows the percentage of valid, error, and empty values in a column. 2. Column distribution. Displays a histogram view of the frequency distribution of unique values in a column. 3. Column profile. Provides summary statistics, mean, median, mode, minimum, maximum, and the distribution of values. / enabling data profiling in Power Query. 1. Go to the View tab in Power Query. 2. Enable the following options: column quality, column distribution, column profile. 3. Analyze the data using the profiling tools. View column profile for detailed insights into a column's distribution. Use column quality to detect data quality issues quickly. View column distribution to identify outliers and unique values. The practical use case. Imagine you are working with a customer sales data set and you want to check for data quality issues in the customer ID column. If you see a high percentage of empty values, it indicates missing data that needs to be addressed. Number 2, handling data quality issues. Common data quality issues. 1. Missing data. Missing values in important fields like customer ID or sales amount can distort analytical results. 2. Duplicate records. Duplicate entries can lead to inflated numbers and inaccurate insights. 3. Inconsistent data. Variations in data entry, e.g. New York versus NY, can lead to incorrect aggregations. 4. Data type mismatch. Fields like date and price may have incorrect data types, text instead of date or number. 5. Outliers. Extremely high or low values that don't make sense in the context of your data. Techniques for handling data quality issues in Power Query. 1. Remove duplicates. Use the Remove Duplicates option in the Home tab to clean duplicate rows. 2. Replace values. Use Replace Values to correct inconsistent entries, e.g. replace NY with New York. 3. Fill down, fill up. For data with missing values in a sequence, use fill down or fill up to fill gaps. 4. Split columns. Use the Split Columns feature to handle data entries like first name, last name in a single field. 5. Change data types. Ensure fields have the correct data type, e.g. dates are date type, sales values are decimal. 6. Remove errors. Use the Remove Errors feature to eliminate rows with invalid values. Practical use case. You notice that a column named Sales Amount contains some text values that are throwing errors. Use Remove Errors or replace the incorrect entries with 0 to clean up the column. 3. Advanced data quality handling techniques. Using conditional columns. Create conditional columns to handle missing or erroneous data. For example, if the sales amount is null, replace it with an average value. Using custom functions. Create custom functions in Power Query to handle repetitive data cleansing tasks. For example, standardize country names, e.g. US, USA, United States. Data quality transformation patterns. 1. Imputation. Replace missing values with the mean, median, or mode. 2. Standardization. Convert values to a standard format, e.g. uppercase for all country codes. 3. Normalization. Scale values to a common range for consistency. Practical use case. If your dataset contains multiple date formats, use the Format Dates function to standardize all dates to MMDDYYYY. 4. Implementing data quality checks. Creating validation rules. Create custom columns or conditional columns to flag rows that don't meet quality criteria. Use if statements in Power Query's M language to create complex validation logic. Data quality reports. Use column profile views to generate reports that highlight quality issues. Export quality metrics to a summary table for business users. Practical use case. Create a validation rule that flags customers with missing email addresses. Create a separate table summarizing the number of records that need attention. 5. Optimizing performance during data profiling and cleansing. Best practices for efficient data profiling. Profile small samples first to identify potential issues. Use the data profiler selectively to avoid performance slowdowns on large datasets. Using query folding. Ensure that your transformations support query folding whenever possible. Query folding pushes transformations back to the source system, which can significantly improve performance. Practical use case. If you're connecting to a SQL Server database, use query folding to apply data quality transformations on the server side before importing data into Power BI. Exam tips for profiling and handling data quality issues. Understand the purpose of each profiling tool. Know when to use column quality, column distribution, and column profile. Be comfortable with data cleansing techniques. Practice using Power Query to remove duplicates, handle nulls, and replace values. Create and use data validation rules. Understand how to implement conditional columns and custom rules to flag data quality issues. Optimize performance. Learn to use query folding and other techniques to handle large data sets. Practice scenario. Given a data set with customer orders, profile the data and identify the following. 1. Count of missing values in the customer ID column. 2. Number of unique products in the product name column. 3. Average sales amount after handling missing and erroneous values. Complete these steps in Power Query and document your findings. This guide provides a comprehensive overview of profiling and handling data quality issues, which is a critical area of the PL300 exam. Practicing these techniques in Power Query and applying them to real-world scenarios will ensure you're fully prepared for both the exam and practical use cases. Let me know if you need more detailed explanations or additional resources. Advanced Guide to Profiling and Handling Data Quality Issues in Power BI for the PL300 exam. 1. Deep dive into data profiling with Power Query. Data profiling is not just about identifying obvious issues, such as null values or duplicates. It also involves gaining a deeper understanding of the overall structure, distribution, and patterns of your data. Below are some advanced concepts and techniques to ensure robust data profiling. 1.1. Data profiling concept, data completeness. Are there any null values or missing rows in critical columns? Data conformity. Does the data follow standard rules, e.g. state abbreviations are consistent? Data consistency. Are values across datasets or sources consistent, e.g. customer IDs match across systems? Data uniqueness. Are there duplicate records that may impact aggregations? Data accuracy. Are values in the expected ranges, e.g. negative values in sales are anomalies? 1.2 Advanced Data Profiling Techniques, Column Value Distribution Analysis. Go beyond standard column profiling by calculating the skewness and kurtosis of value distributions to detect anomalies. Example, create a custom query to detect unusually high or low outliers in the sales amount column using M-code. Cross-column data profiling. Perform correlation analysis between multiple columns to identify relationships or dependencies. Example, identify if product category and sales region columns show unexpected combinations that indicate data entry errors. Text data profiling. Use the text.length and text_contains functions to profile text columns, such as detecting email addresses that don't contain @ symbols. Example, create a flag column that identifies invalid email formats. M if text.contains email @ equals false, then invalid email, else valid. 1.3 Using M language for custom profiling. The M language in Power Query can be used to create custom profiling metrics. Identify top n frequent values, mtable.group, source, column name, count each table.row count, type number. Calculate conditional value distributions, mtable.group, source, category, conditional count each list.count, list.select, 1000, type number. This allows for tailored profiling to suit specific business rules and requirements. 2. Handling data quality issues, a structured approach. A systematic approach to data quality issues involves detection, categorization, resolution, and validation. Each issue should be analyzed based on its impact on the analytical outcome. 2.1 Data cleansing operations, standardizing values. Use Power Query's transform options, uppercase, trim, clean, to ensure uniformity in text fields. Example, standardized state abbreviations, mtable.replace value, previous step, each state, each if state equals ny, then New York state, replacer.replace text, state. Handling missing data, imputation, replace missing values with a placeholder, average, or another statistical method. Deletion, remove rows that contain nulls in critical columns. Example, replace missing sales with the average of the column. mtable.transform columns has to have previous step, sales, each if equals null, then list.average at previous sales, else. Creating reference tables for data quality rules. Build a reference table that defines acceptable value ranges, patterns, or business rules for your data. Example, use a product reference table to validate product ID entries in a sales table. Pattern 2.2, data quality patterns. Data deduplication pattern. Use group by to identify unique records. Example, use a group by operation to count the number of duplicate records based on customer ID. mtable.group source customer ID count each table.row count or type number. Data type enrichment pattern. Use the add column option to derive new insights. Example, create a sales category column based on the sales amount. If sales amount 500, then high, else if sales amount 100, then medium, else low. 2.3, handling complex data quality issues with conditional logic. Advanced transformations often require complex conditional logic. Nested conditions. Use nested if statements in Power Query to handle multi-level logic. Example, categorize customers based on both sales and region. If region equals north and sales 1,000, then priority customer, else if region equals south and sales 1,500, then high value, else standard. Dynamic error handling. Implement error handling logic to capture unexpected values. Example, create an error log table to store rows that don't pass validation checks. Building automated data quality pipelines in Power BI. Using Power Query's advanced editor, you can automate data quality checks and cleansing operations. Consider creating a multi-step pipeline for complex scenarios. 1. Initial profiling. Generate a summary report of key columns using column profile. 2. Data quality check. Create a custom function that iterates through each row, applying business rules. 3. Cleansing and transformation. Apply advanced transformations such as replace errors and conditional transformations. 4. Final validation. Implement validation steps to flag unresolved issues and log them for review. Example M code for a data quality pipeline. M let source equals excel.workbook file.contents C sales data.xx null true data equals source name sales data replace missing table.replace value data null unknown replacer replace value customer name remove duplicates equals table.distinct replace missing add flag column is table.add column remove duplicates quality flag each if sales 0 then negative sales else valid error log equals table.select rows add flag column each quality flag negative sales final data equals table.select rows add flag column each quality flags valid in final data. This code cleanses the data, flags quality issues, and separates them for further analysis. 4. Creating data quality reports in Power BI. Finally, create data quality reports that highlight issues and their resolution status. Data quality metrics track the number of missing values, duplicates, and invalid entries. Data quality trend analysis show how data quality has improved over time. Use conditional formatting and custom visualizations to provide a clear view of the data quality landscape. Practice scenarios and exam preparation tips. 1. Real-world scenario practice. Profile and cleanse a messy data set with missing values, inconsistent text formats, and duplicate entries. 2. Hands-on in Power Query. Use the advanced editor to create custom scripts for complex data transformations. 3. PL300 exam tip. Expect questions that test your understanding of profiling tools and how to resolve specific data quality issues using Power Query. Be familiar with the M language functions such as table transform columns, table.select rows, and custom if statements. With these in-depth techniques, you'll be well prepared to handle complex data quality scenarios in both the exam and real-world contexts. Let me know if you'd like more detailed examples or have any specific questions. Advanced concepts in profiling and handling data quality issues for Power BI PL300 exam. 1. Deep dive into advanced data profiling and cleansing strategies. 1.1 Advanced profiling strategies. Data profiling is crucial for analyzing data at a granular level. While Power Query's built-in profiling tools like column quality, column distribution, and column profile provide excellent high-level insights, deeper issues often require custom strategy. Advanced concepts in profiling and handling data quality issues for Power BI PL300 exam. 1. Deep dive into advanced data profiling and cleansing strategies. 1.1 Advanced profiling strategies. Data profiling is crucial for analyzing data at a granular level. While Power Query's built-in profiling tools like column quality, column distribution, and column profile provide excellent high-level insights, deeper issues often require custom strategies. Cross-column profiling. Analyze relationships between columns to detect inconsistencies. For example, a combination of product category and product subcategory that doesn't exist in the reference table is a clear indicator of a data quality issue. Example, calculate correlation or flag invalid combinations using MCode. mtable.addColumn, previous step, category check, each if product category equals electronics and product subcategory equals clothing, then invalid, else valid. Data drift analysis. Use historical data to identify whether the distributions of key metrics are changing over time. Data drift can signify that data sources have changed or data entry errors are occurring. Implement rolling average or rolling standard deviation calculations in Power Query to detect drift in numeric columns. mtable.addColumn, previous step, rolling average, each list.average, list.first, and 10. Hash dependency profiling. Identify if certain fields are dependent on each other. For example, if country is filled but state is null, it may suggest an issue with location data completeness. Use a conditional column to highlight missing dependent fields. If country null and state equals null, then missing state, else valid. Now track 1.2, profiling with statistical measures. Integrate statistical concepts into your profiling to identify skewness, kurtosis, or outliers. Skewness and kurtosis. Calculate skewness and kurtosis to understand the symmetry and peak of the distribution of a numeric column. MCode implementation of skewness. Let source equals table dot from records, value 10, value equal 20, value 1535, mean equals list.average, source value, std equals list.standard deviation, source value, skewness equals list.sum, list transform, source value, each power, score minus mean 3, / list.count, source value 3 in skewness. Outlier detection using z-scores. A z-score can be used to detect extreme outliers. Any value with an absolute z-score 3 is typically considered an outlier. Implementation. Let source equals table dot from records, sales equal 100, sales of 200, sales of 300, sales equal 1000, mean equals list dot average source sales, path data and list dot standard deviation source sales. Z-score table dot add column source z-score each sales that's mean / that's the dev in z-score. 2. Complex data cleansing patterns. To handle advanced scenarios, employ sophisticated patterns for data cleansing. 2.1. Multi-column transformations using list functions. Perform complex transformations using list operations. Use list.accumulate for conditional aggregations. Aggregate values based on a complex set of conditions. Example, calculate a conditional cumulative sum for a specific category. Let source equals table.from records, category equals A, sales of 10, category equals B, sales of 15, cumulative sum equals list.accumulate, source sales 0, state current. Also, if current 10, then state plus current else state in cumulative sum. Checkers 2.2, using recursive functions in Power Query. Implement recursive logic for scenarios where a transformation step relies on the previous state of a column. Example, creating running totals using recursion. let source equals table.fromRecords, month equals 1, sales 10, month of 2, sales 20, month of 3, sales 15. Add running total equals table.fromList, list accumulate, source sales, state current, state and list.sum states current, splitter.split by nothing, running total in add running total. Nav 2.3, pattern matching and text cleansing. Use the text.select, text.contains, and text.replace functions for pattern matching in fields. Use case, clean a column containing improperly formatted phone numbers, e.g. 12345678890 versus 135678890. Code, table transform columns, previous step, phone number, each text.select 0, measure regular expressions in Power Query. While Power Query doesn't support native regular expressions, use combinations of text.start, text.middle, and text.end to replicate regex patterns. Error handling and logging strategies. Handling unexpected errors systematically ensures that your data quality framework is robust, and 3.1. Error handling patterns in Power Query. 1. Using try otherwise blocks. Implement try otherwise statements to catch errors and replace them with default values or log them for analysis. Example, replace errors in a calculation with 0, table.transform columns, previous step, sales amount, each try, quantity otherwise 0. 2. Creating an error log table. Use try blocks to capture errors and create a separate log table for quality auditing. Implementation, let source equals table.fromRecords, sales equals quantity 2, sales equals 10, quantity equals null. Error check, table.transform columns, source, sales amount, each try, quantity, otherwise error. Error log equals table.select rows, error check, each sales amount equals error in error log. 3. Recursive error handling. Implement custom error handling functions to handle nested data structures or recursive operations that might fail under specific conditions. Example, input table as table equals, let handle errors equals try, table.transform columns, input table, amount, each at 0, then error negative value else, otherwise input table in handle errors. 3.2, building robust validation frameworks. 1. Validation rule engine. Create a framework for applying validation rules dynamically. Use a parameterized query that accepts rule definitions and checks the data against those rules. Example code for a dynamic validation function. Data as table, rules as list as table, let apply rules if list.accumulate rules state rule, table.add column state rule name, each if rule condition column, then fail else pass in apply rules. 2. Automated data quality reports. Create summary tables that show the number of rows failing each rule, providing an overall data quality score for each field. Implement conditional formatting and dynamic KPIs in Power BI to visualize data quality trends. Automating data quality processes. To maintain consistent data quality, automate repetitive data cleansing and validation tasks. 1. Dynamic data pipelines using parameters. Use parameters in Power Query to create dynamic, reusable data quality processes. 2. Parameterized queries for custom rules. Example, create a parameterized query that adjusts validation rules based on user inputs, such as acceptable value ranges or data type requirements. 3. Power Automate integration. Use Power Automate to schedule and trigger data quality checks on data refreshes, automatically logging results or sending alerts for quality issues. Example, set up a Power Automate flow that triggers a data quality check in Power BI and sends an email alert if certain thresholds are breached. By mastering these advanced data profiling and cleansing techniques, you'll be able to tackle even the most complex data quality challenges with confidence. Let me know if you'd like further details on any specific pattern or technique.